All right, good evening, everybody. It's my pleasure to welcome everyone to our final lecture of the year. I'm Dr. Josh Coco, Executive Director for the Rosenstiel School, and I'm filling in for Dean Avisar, who could not join us this evening. Although we are virtual and despite the pandemic, we are pleased to be able to officially conclude what was a milestone for our series, the 25th anniversary of Sea Secrets. Before I move on, I want to thank you for joining us tonight for this session with Dr. Robin Bell, Palisades Geophysical Institute and Lamont Research Professor from the Lamont-Doherty Earth Observatory of Columbia University. I also want to give a special thanks to our Sea Secret sponsors and the many friends who contribute to the Rosenstiel School. These sponsors include Bank of America, the Shepard Broad Foundation, Meredith Ann Dasberg Foundation, William J. Galway III, Cheryl Gold, Key Biscayne Community Foundation, Elizabeth C. Lambertson Foundation, Joan McCon Family Foundation, Taylor and Melissa White Fund, Myron and Nicole Wang, the Welch Family Foundation, and Southern Glazers Wine and Spirits. Thank you all for supporting Sea Secrets. This year has been like no other in the history of our school. We've redefined our work, teaching spaces, academic programs, and processes to safeguard the health and well-being of our students, faculty, staff, and our community. We reopened for the fall semester with teaching simultaneously in person and virtually to accommodate both students' learning needs and to adhere to on-campus restrictions. I've never been prouder of our school and more humbled by the generosity and spirit of our faculty and steadfastness of our staff. I'm reassured to know that in spite of the tough situation that we have been managing, the Rosenstiel School remains a unique beacon of light that will continue to navigate through this storm. Today, the need for financial support to our school, faculty, and our students is greater than ever before in our history. This month, National Philanthropy Day will be celebrated on November 15th. It presents an opportune time for us to reflect on gratitude, affirming that there are good things in the world, gifts and benefits we've received. It requires us to see how we've been supported and affirmed by other people. For this, we are forever grateful. Many of us have felt the impacts of the pandemic personally and professionally, but through it all, we remain grateful, for it strengthens and grounds us to endure what we may not have anticipated. Now more than ever, we are grateful for your friendship, your support, and generosity. And now on to our lecture. Please remember to put all your questions into the Q&A feature at the bottom of the screen so we can begin organizing them for this evening's speaker. Tonight, I have the pleasure of introducing you to one of our notable graduates of the Marine Affairs and Policy program. Hilary Sunell is a leading environmental and sustainability law and policy professional in the New York City region with expertise in urban resiliency and coastal zone management issues. She is currently the Director and General Counsel of the Mayor's Office of Environmental Coordination, which oversees environmental impact review and green building compliance for New York City's major infrastructure, capital, planning, and legislative projects and initiatives. Hilary also is a part-time faculty member in the Environmental Policy and Sustainability Management graduate program at the New School. Before working in government, Hilary led the Eastern Environmental Law Center, a public interest environmental law firm based in Newark, New Jersey. She has served on the board of directors for the Lower East Side Ecology Center, Sustainable South Bronx, New Jersey Earthshare Coalition, and is a pro bono counsel to the New York City Urban Green Council. Hilary has a JD and a master's degree in marine affairs and policy from the University of Miami, in addition to her undergraduate degree from Barnard College. Please welcome Hilary Sunell.
Hi, everyone. Thank you so much for inviting me to this important event. I really miss attending Sea Secrets in person. I've been in New York too long. As you heard, I graduated from Rosenstiel, the MAF program in '95, and then I went on to University of Miami's law school and graduated in '98, and then continued my career in the New York City area, but I have been practicing nationally and internationally for my entire career. I came to Erasmus because I was looking for a program that offered marine and environmental policy in a master's program, particularly with a focus on coastal zone management issues and climate change issues, and has a collaborative and cross-disciplinary approach. I was very lucky to work on a wide range of projects and study at Erasmus. I was working in the physical oceanography department. I worked on marine archaeology projects, tribal justice projects, and I also had the opportunity to work at an education program at the Miami Museum of Science, which is now the Frost Museum of Science, and at the Mast Academy. Um, my the my experience at Rosenstiel School has prepared me for my career. I am an environmental and sustainability professional, so that means I work collaboratively with many different people in the discipline. I work with engineers, scientists, community activists, public administrators. I work cross jurisdiction with the city, with the state, and with the federal government on very large infrastructure projects. And I'm working particularly with New York City to revitalize New York City's marine and coastal waterfront. So one of the projects that I am most proud of is working with the New York City Economic Development Corporation on launching the new New York City ferry service, the citywide ferry service. It's been operating for 3 years. The mission of the project was to bring a sustainable and resilient mode of transportation to areas that were underserved by traditional transportation like subways and buses. Those areas are particularly Rockaway Beach, Coney Island, and the Soundview Peninsula in the Bronx. The ferry service has expanded throughout the East River. It will be expanding to the Hudson River and possibly to New Jersey next year. One of the very interesting things that we were able to do through the ferry service is not only bring a ferry service to New York, but to also engage shipyards in Alabama and Louisiana to build the type of engines that we thought would be the most sustainable for New York City and to keep emissions low in New York City. So New York City created the standard for Tier 4 diesel ferry engines, and now has the first operating Tier 4 engine within the New York City harbor area. So I'd just like to share a picture and welcome everyone to, when they can, come up to New York and enjoy our ferry service. Like Rasmus, we also have a bar on every ferry, so it is a fun experience. Hold on, I cannot find where to share my picture now. Josh, are you able to share it? I lost my share button. Oh, here we go.
You got it? Okay, perfect.
Oh, I got it, sorry. So here you see one of the brand new ferries that is crisscrossing the East River daily. I'm very lucky to have a ferry stop by my house, and you can take, this is not one of the ferries that goes to Rockaway Beach because it's slightly larger because it has an oceanside landing, but these are the ferries that go up and down the East River from South Brooklyn to the Bronx. And it's the nicest thing about it is it's affordable at the same price as a subway ride. Was even used for emergency response. The idea from the ferry system came as an emergency response to Sandy, when many modes of transportation, Hurricane Sandy, when many modes of transportation were halted because of flooding. And we thought that a ferry service would be a way to provide transportation under those emergency circumstances. Little did we know we are also using the ferry for emergency response due to COVID to try to keep transit going, but have social isolation. And I am very happy to answer any questions anybody may have. And also if any alumni or students would like to reach out to me, you can find me. The website is the New York City Mayor's Office of Environmental Coordination. Thank you.
And Hilary, really quick, can you try to stop sharing and share it again and share just the photo? I think it's only sharing the browser screen right now.
Oh, really? Sorry. Okay, hold on. Wait, hold on. I don't know why it's not sharing the photo. Hold on, let me try another
There
way.
we go. That was better a second ago.
That was better. Okay, hold on. Let me try another way. Hold on 1 second. Is that better?
No, we're just seeing that same box thing of
Okay, hold on. I don't. Okay, let me try it. I have it in my. Well, you can also go to the website and the photos there. But let me see. I have it another. Let me try it one more way, and I don't want to delay this too long. Hold on. I can't. I don't know. Sorry about that. It's not letting me share. Hold on 1 second. Let me try.
there we go. There we go. Right there. Leave it right there.
Okay, sorry. I can't see it now, but I see what I can see them out my window.
Perfect.
So yes, everybody come to the New York City Ferry when hopefully we can travel again. And thank you again for letting me talk about my Erasmus experience, Rosenstiel experience. I'm dating myself.
Awesome. Thank you so much, Hilary. It's always nice to bring back amazing alumni to campus, even if it's virtual. So hopefully we can all meet up soon. And next, to introduce our speaker this evening, please welcome Professor Dennis Hansel, who is a professor of ocean sciences and conducts research on the biochemistry of carbon in the global oceans.
Thank you, Josh. It's my pleasure and honor to introduce you all to Dr. Robin Bell. To begin, I'd like to share a great photo of Robin and myself taken just last December at the American Geophysical Union's fall meeting. And let's see if I can make this work. Is that coming through for anybody?
Looks good.
All right, great. So this is the elegant Robin Bell, just so that we all know how she dresses on a daily basis. And it was fun. We had a big banquet that evening and dancing and that sort of thing. I didn't get to dance with Robin, but so you know how she dresses on a regular basis. So let me stop sharing that. All right, so let me tell you a little bit about Robin. She received her undergraduate degree in geology from Middlebury College in Vermont and her Ph.D. in geophysics from Columbia University in 1989. She has explored our planet's ice sheets, massive ice sheets on Greenland and Antarctica, which we will learn more about this evening, using innovative technology that she developed. She has coordinated 10 major aerogeophysical expeditions to Antarctica and Greenland, studying the mechanisms of ice sheet collapse, discovering a volcano beneath the West Antarctic ice sheet, as well as several large lakes beneath 2 miles of ice. Imagine that. And demonstrating that ice sheets can thicken from below. She led a Lamont research team to map the Hudson River from Staten Island to Albany. Robin was the first woman to chair the National Academy of Sciences Polar Research Board from 2002 to 2008, and she launched the International Polar Year from 2007 to 2009 that coordinate the activities of over 50,000 scientists from around the globe. Dr. Bell is president of the American Geophysical Union. That's a big union. I think there's on the order of 66,000 members, the world's largest Earth and space science society. Equally important, she has worked hard to improve the culture for women in science. Robin is deeply committed to diversity in science and beyond, and we thank her for that dedication. It takes heroes like that. So Robin, welcome to Sea Secrets.
Well, thank you very much, Dennis, and thanks for sharing that wonderful picture. We as scientists don't often get to honor the amazing people in our community and also get to go dancing with them. So we were probably on the dance floor together. Thank you very much for inviting me I do wish I was there in person. It's funny that Hilary and I are both sitting on the waters of New York while we wish we were there, sitting, looking over the waters of Miami with you. But we're looking forward to the time we can get together again. And today, well, I often just talk about ice and climate. I thought I'd talk a little bit more about how climate, COVID, and racism actually are really what are both in our face right now, but also I often think of that, don't panic moment from Hitchhiker's Guide to the Galaxy. And, we really are a place where we have a chance to look at solutions. So I hope you'll enjoy this journey with me. Next slide, Kat. So where are we going today? We're going to talk about these 3 tough problems that are facing us as a species today. They're politically charged. They're intertwined. COVID and climate impacts minority communities disproportionately. But they're all addressable using the same approaches. And as you might imagine, very much scientific-based approaches. And now it's really a unique opportunity for each one of us to make a difference on all these tough problems. Next slide, Kat. So where are we going to go? I'm going to take you on a brief tour about how our planet's changing, ice sheets, and I don't really have to tell you guys about sea levels, and look at how we can take action individually, organizationally, and culturally. I'm going to look briefly at the global nature of our modern lives and why Hilary and I are here and not in Miami. And then look at the inequitable impact of the pandemic and the recognition that has been right in front of us all of the widespread systemic racism, and look at what we can do about these tough problems, and look for the roles we can play, and look for the levers. Each one of us has levers we can change and use to foster change. We can take action. Next slide. I always like just to take a moment to reflect on how fortunate we all are. We're in the 21st century. We're in a moment where we have science at our fingertips to really benefit humanity. We have science that uniquely positions us to understand how that beautiful marble, that beautiful blue marble of ours, oh my goodness, I'm at my office. I can hold up the one I have on my desk. This beautiful blue marble of ours works. Next slide. On our planet, there are really 2 poles. I've had the fortune to go to both of them. And there are 3 ice sheets. And when I started studying the ice sheets, it really seemed impossible they could change. The first paper I published, I actually had to take out the words that they could change fast. Now we know they both can change. The one in the north gets our weather very much. Greenland often gets the same, here we see the weather and 2 days later it's in Greenland. West Antarctica and East Antarctica are much more isolated. Antarctica makes its own weather, is isolated from the rest of the planet pretty nicely. Next slide. And we have heard this continual drumbeat of how the ice is changing. The very clear, most visible one is that the Arctic sea ice has dropped. We hear it most times of the year in September. We hear that we've reached a new minimum. This is just a map that shows how from the 1980s to 2016, just how much less ice there is in the Arctic. And I can remember, next slide. Yes, thank you. I can remember how in the 2000s, which you can see on that, there was just about before it started to drop off really precipitously. We in the science community were still arguing about whether or not there was change or if it was just interannual variability. We now know that it's change and we're responsible for it. Next slide. We're going to look at the ice sheets. So we're going to look at Greenland, Antarctica, just to show you, because I always like to show people what the signature of the change is. In Antarctica, you can see this shows in the 1990s, the ice was flowing about 2 kilometers a year, about a mile a year. And by the about a decade later, it had doubled in speed. One symbol, one clear set of data that the ice sheets are changing. The other data set that I love to show people is the one that's now showing up in yellow. Where it's yellow are places where we measured with a different instrument, we could actually see the ice surface dropping up to about 60 meters over the course of a decade. And because ice is like mozzarella cheese, the same places it was speeding up were the same places the ice sheet is getting lower. Just think about how when you bite a piece of pizza and the ice stretches, that's what's happening here. We're seeing the ice get lower. Next slide. And just because scientists like to really make every single measurement they can to make sure they're really right, where you see it growing red here is where we can actually measure from space how much the ice sheet weighs. And where you see the red blobs having grown, we actually can measure that the ice sheet has lost mass. So in one place in the ice, we can see it's going faster, getting lower, losing mass. There are places you can see around Antarctica, it's actually snowing more in those blue places mostly. But that extra snow isn't making up for the ice that's catapulting itself into the global ocean. Next slide. And I hardly have to tell this community that there are local impacts. This is something that's always struck me. I'm a sailor, so I traveled around on our sailboat. This is a picture of the coast in Dakar. Next slide. And while like Hilary, my husband works very much in water quality and environmental issues, and we were there to talk about water quality. But it turns out that every single one of these water quality experts from around West Africa was worried about sea level rise. And here we're standing at Ile de Gorée and seeing the impact of rising sea level on that very historic site. Next slide. When you look at what's happening around the globe, you can see almost everywhere the sea level is going up. That's what those little arrows mean, whether it's Miami or New York. In questions, I'm happy to talk about why we see it going down in Sweden, in Hudson Bay. But the general signal is up. Next slide. And even in Miami, you know, there's a pipe right down there in the water that's been there pretty much since 1930. And it's going up about 3 millimeters a year. So what does that mean? That means in the last 100 years, if you put your leg probably just below your knee, you know, it's gone up that much in the last 100 years. I always find that really useful to think, because when I say millimeters, what does that mean? It doesn't really mean, but we can feel what it means for the water to have gone halfway up your knee. So it's a global problem with local impacts. Next slide. And, you know, while you in Miami live through king tides and are hoping that we can tell you exactly what's going to happen in the future, that's one of the challenges, is that we as scientists have now understood the ice sheets changing. But just like 30 years ago, we weren't as good at predicting the tracks of hurricanes. We aren't as good as we need to be yet on predicting how sea level will rise. Next slide. And this is one of my favorites. And, you know, I like to think of this as my grandmother, my 2-meter tall grandmother on the right, showing the range of projections we have right now. We need to understand how ice sheets work better, because you in Miami, we in New York, Hilary for her work, we all need to know how that sea level is going to change in the future. Next slide. And the reason we can't give you the talk, the answer is the models aren't there yet. This is one of a friend of mine's. He's been just showing how melt will form in the future on the ice sheet and how that melt will make the ice collapse and disappear. But the problem is we don't have the physics right in these models yet. It's one of the challenges. Matter of fact, as soon as he published this, I said, you know what, Rob, that's a beautiful model, but I can already see the things that are not quite right in it. Next slide. So what's my job? My job, as Dennis said, is to push the frontiers of knowledge, to find discoveries, to inform those projections. I don't like having to tell my friends I don't think their models are right or as good as they need to be, but That's what happened with the process of weather forecasts. We've gotten better and better at being able to predict weather because we put better physics. We understand better how the ocean works, how the atmosphere works, how hurricanes form. Next slide. So before we dive into what we can do about COVID, climate, and racism, I just want to take a quick tour into some beauty and wonder to remind ourselves of the amazing place our planet is and what science can tell us and how it can just make us go, wow, isn't science and our planet a beautiful place? Next slide. And really my job is very much like those hurricane, you're so used to hearing when NOAA sends out the P3s to measure the ocean temperature when there's a hurricane coming. That's the same thing we do. This is us doing a very similar thing, only it's a C-130 and throwing an Alamo float. It's an airborne instrument that we can deploy from the air that will measure how warm the ocean is and how saline it is, because we need to understand that to know how the ice is going. So that's my job, getting up close and personal to see what you can't see from a satellite. Next slide. Oops. So how do we understand change? I've shown you that we can see it going faster, getting lower, weighing less, but we need to look underneath. We need to see what that ice is made of so that we can make those projections better. Next slide. So just because it's one of those wonderful things, if you've ever skied on a glacier, it's pretty rough. That's what the picture on the bottom is skiing on a glacier. If you've ever had the opportunity to ski or skate on a lake, you know how flat it is. It's like Miami on a dead calm day. Next slide. And it turns out that if we look at the surface of the ice sheet in Antarctica, and this is one of the first images of the ice sheet we had from space, what you can see is there are places it's pretty rough. Can you click it once more, Kat? And it's pretty rough, and that's places where the ice is stuck to the ground. But there are other places that you can see it's really, really flat. And what that is those are places that it's actually floating. Or, as Dennis alluded to, there are actually lakes beneath 2 miles of ice. Next slide. You can even see them if you stood back and look at a whole map of Antarctica. And that's the one that's called Lake Vostok. It's with a little yellow arrow pointing at it. And it's the size of New Jersey. Just mind-boggling. Next slide. And if you look at it in cross-section, it's actually where they drilled one of the very first very important records of climate change for the last 400,000 years. And I flew an expedition over it where we measured the ice flowing over it. We found out that some of the ice, actually the lake water froze back on to the bottom of the ice sheet as it crossed the lake. Because in fact, if you're looking at this, the ice is flowing from left to right across that lake. And the lake is as big as those lakes we see in East Africa. It's about almost 1,000 meters deep in places and circulates very much like an ocean. Next slide. So it turns out that Lake Vostok's not the only lake in Antarctica. You could see other ones in that surface image I showed you. But what I do is I put instruments on aircraft that let me do kind of like CAT scans of an ice sheet. So what we're looking at here is you can see there are mountains at the bottom. Some places you can see layering in the ice because the ice is kind of like a tree ring. Every year you get a distinct signature on it. And then in the bottom of the valley, you can see a very bright, shiny reflector that's water. So when we map all of those, next slide, please. All those little dots let you know that how many places there are lakes beneath the ice sheet, suddenly making us realize that while we think of Antarctica as being this flat, white, boring place, in fact, it's a quite rich, remarkable environment. Next slide. That's what it looks like when you stand on top of Antarctica, deep in the interior with that beautiful blue sky because the atmosphere is so thin. But it turns out that not only there are lakes underneath, next slide, but there are mountains too. And during the International Polar Year, I was fortunate enough to lead an expedition with 7 nations where we went to explore this mountain range, which is the last unexplored mountain range on our planet. Next slide. They discovered it when I was, the year I was born, when they first drove a snow vehicle across the top of the ice sheet and found the ice was very thin, but nobody had been back there for 50 years because it really took 7 nations to get there. So with 7 nations, we've surveyed that area, the size of California. That's what all those little lines are. They're driving back and forth. It's like we drove a plane down every single one of those lines. Took us 3 weeks. We had the planes in the air pretty much 24 hours a day whenever we could, because there was such a narrow window where it was warm enough to work. Next slide. And this is what it looks like underneath. We went from seeing this, not knowing really what this mountain range looked like, to realizing there was this spectacular mountain range the size of the Pyrenees or the Brooks Range. That's one of the aircraft we used to survey it. And when we wrote the proposal, we said we were going to look for water, but we hadn't really expected we were going to see water. Next slide. And this is, again, now we're looking down at the mountain range. I've taken just black, it's very deep. So those are the river valleys, and I've taken the ice off. And what we were really surprised, next slide, is that everywhere we looked, there's a little green dot. Turns out there was water everywhere in this mountain range. In every single valley had water in it. Next slide. And we're going to zoom in and to look at, this is like one little set of cirques, kind of a nice place to go skiing. Next slide. We're going to step through these. So every single valley had water in it. You can see those green dots. And we began to think, what's up with that water? And we suddenly realized that because of the way the ice sheet was sitting on top, where it was thicker over the downstream parts of the river and thinner over the upstream parts of the river. Can you click a couple times, Kat? Probably, yeah. You're going to keep on going. I'll tell you when to stop. Okay, you can probably stop and go back. And you can see that what actually was happening was this was probably one of the special places in the world where the water was being driven uphill because of the weight of the ice on top of it. Crazy. A land where rivers run backwards. Next slide. It was one of those tremendous moments in science where you go, oh my goodness, what are we seeing? Next slide. We were wondering whether it was altitude sickness. But at the same time, we were seeing, these are actually notes from the field logs. And again, I hope I've shown you enough that you can see the stuff that's layered is the ice, and then the stuff that's kind of pointy at the bottom is where the mountains are. But there are these funny clouds. We aren't used to seeing clouds at the bottom of the ice sheet. And you can see the person who was taking notes said funny double peak. Next slide. And then there was something that was even weirder, where again, you can see the mountains there at the bottom, and then you see the nice layers on top of that. And then there's this giant blob. And my friend Michael said, looks like a big mountain, a dental x-ray, maybe a magnetic anomaly. Next slide. And then my friend Beth saw another one. She again saw mountains on the bottom, layers on the top, and something in between. And when we got home, next slide, we realized that when we looked at it, it looked an awful lot like Vostok, and that it had this funny triangular shape where it looked like as the ice flowed over this water, something was happening, as if maybe it was freezing on from the bottom. Next slide. Maybe one more. So we mapped them, and we found that those clouds, blobs, we never have come up with a good name for them, sit at the end of all those valleys that I looked at before. Next slide. They were up to 60 kilometers long. One more, we're going to slip in to zoom in, Kat. And so that's where we saw that the water was running backwards. And now, can you click a couple times? And we're going to fill in this. You can see the water in the valleys. And there are the blobs, those structures at the bottom. And then you can see the water running up to fill them. So what we have interpreted that's happening is this is a place where, because of the ice sheet, the water is running back uphill. And next slide. And one more, yes. And what you can see is that you're actually freezing the ice onto the bottom of the ice sheet, almost half the ice sheet thickness, 100 football fields. A spectacular one of those moments. It's like, wow, the world is a remarkable place. You can actually drive water uphill. You can put water back onto the bottom of an ice sheet. Next slide. You know, it's just one of those moments where you realize how lucky we are to be able to go and understand how our planet works. And it's that knowledge of how our planet works is what's going to allow us to continue to live on this planet. This is actually not Antarctica. This is Greenland. This is what it looks like when you look out a window down into on the Greenland ice sheet. Next slide. And yeah, our ice sheets, our planet is changing. The temperatures are warmer. We're seeing longer growing sheets, and we're even catching different fish, depending on what your favorite signal is. Next slide. The global temperatures are really warming everywhere. It's been quite a clear positive trend. If you look back at the time frame, same time frame, we were seeing sea level going up. Next slide. And what's remarkable is it's changing everywhere, but it's not changing the same everywhere. So if you have relatives in Louisiana, in parts of Louisiana, Mississippi, or Alabama who are saying they aren't seeing it changing, they're probably right. The annual temperature is not changing the same everywhere. Some places are changing faster, different seasons are different. I like to say it's kind of like the refrigerator. You know, the refrigerator has different temperatures in it. So does our planet. Next slide, please. The growing seasons are getting longer. As I like to say, in my backyard, the daffodils come up much sooner, and I can continue to harvest tomatoes and basils much later into the fall. And it's on average 10 days longer in the US, in some places as long as 40 days. Next. And if you talk to people who fish in the Gulf of Mexico, you'll actually find that they aren't catching cold-loving fish, the southern flounder, but they're much more likely to be catching the gray snapper. Again, symbols other than wiggles on chart that we really are seeing a change in our planet. Next slide. And what we have seen is if we look at who's being impacted, the poorest communities are being impacted the greatest. This is a direct damage by county as a function of income. And you can see that on the left, the poorest counties have the greatest impact. Next slide. And the greatest predictor in Hurricane Katrina of whether or not that your region was impacted was whether you were a renter, not whether it was poor, not whether you were unemployed, but whether it was African American. Clearly, climate and climate change are disproportionately impacting minority communities. Next slide. As we look to the future, the climate issue really is both global and local. You know, the vulnerable are impacted first. It's essential that we use climate in all the decisions we make at all the scales. And really now's the time to act. And it's time to act individually, culturally, and organizationally. So what does that mean when I talk about climate? Next slide. In my family, we spend a lot of time talking about what our carbon footprint is. My husband's is ridiculously low. That's his book on the lower left, How to Live Sustainably. And so this seems quaint now that I'm not traveling anymore, because we've actually spent a lot of time tracking our carbon footprints. And this was mine for 2018. And you can see that, you know, sort of the background, slow growth over time is sort of growing over time. And you can see where I took a train to NASA, stepped up, flew to Florida for a meeting, flew to Ohio for a lecture, kind of flatlined when I went sailing because we don't use much fuel then. Flew to Mexico, you can see there's a big jump, and then you can see my slope in the winter is much steeper because I use a lot more energy than when I ski. So, you know, when I was traveling, I have very average, well, I had a relatively low 9 tons. The US average is 20 tons. Next slide. And this is really what forms much of our conversation at home. Next slide. But I feel like it's really important that organizations step forward. We heard from Hilary how she really worked to make sure that the engines were responsible on the ferry service they put in New York. At Lamont, we feel like since we're climate scientists, we've worked to get 75% of our electrical needs from solar farms. Next slide. At AGU, I'm currently the president, and that's where you saw Dennis getting his fellowship last year. And we renovated our building, and instead of renovating it as would have been easy to do, next slide, we actually renovated it as the first net zero building in Washington, net zero renovation in Washington, D.C. by you. And again, it's like so many things. It wasn't just one technology. It was solar array, vertical wall of greens to clean the air, LED lighting, and a heat pump, which grabs or dumps heat into the Washington, D.C. sewer system. Putting all those technologies together, you can even renovate a relatively interesting building to make it net zero. Next slide. And so that's sort of what you can do as an individual. You can see what you can do. You can encourage your organizations to, but then there's a cultural question. In our community, Dennis and I are very keen to go to the annual fall AGU meeting where we meet our colleagues, we get to learn new things. And it had been, while the early generation had been really encouraging us to consider taking a virtual meeting because of the 80,000 tons of CO2 that we as a community burn. We hadn't really gotten our heads around it, but this year, as you can imagine, we're doing the cultural experiment. You know, it is our opportunity to see if we can change our culture and continue to build a vibrant science community while having a virtual meeting. So this is an example of a cultural change where seeing if culturally we can move from the concept of needing to get together every year to possibly only getting together less often, or making sure that the meeting's available to people who can't fly and stay in an expensive hotel for a week. Next slide. So now let's just take, we've looked at the climate piece. Now let's take a look at the COVID piece for a second. Next slide. It is our public health moment. I often think that addressing climate really is a public health problem because it requires us to look at the system as a system. And now we are really being forced to look at the consequences of our global community. Next slide. And as we all know, the consequences of our global community is that a virus that can start on one continent can rapidly, because we love to fly and because we love to gather and because we love to share our time with one another, this virus has exploited our love of travel, our love of community, and is now forced us into this new weird Zoom world. Next slide. And we now, my epidemiologist friends told me in March, remember, this is not a weekend camping trip. We're on an expedition. And I've been on a lot of expeditions, and I'm now, both to the poles and offshore sailing. I'm beginning to wonder if really this is much more like an expedition to a different planet. And maybe it will be a different planet. Maybe it's one where we're going to learn a little bit more. Next slide. About how we deal with things. It's interesting when you look to see the communities and the countries that are doing very well are the ones that are in the habit of respecting science and using science to guide their action. Really always intrigues me that New Zealand and Iceland, Japan and South Korea communities, well, South Korea is probably because they had the SARS epidemic, but the other three are places that where earthquakes, volcanoes are part of the daily life there, and the science around them informs decisions. So the concept of needing science to inform decisions around a pandemic wasn't foreign. Next slide. And I'm sure, you in Florida have been, just as I have been, learning to live by what the counts are, what's going on. Next slide. And we're finding that we're using real-time data to make real-time life decisions. I mean, I just took your dashboard, but when my husband's trying to take the sale to the sailmaker, I check that we ripped this last week, and I'm check before he takes it to the sailmaker. I check to see what the caseload is in the town where the sailmaker is. Suddenly we're finding we're using real-time science to make real-time decisions. Next slide. And when you look at this curve of this expedition we have been on as a country, you can see, next slide, those inflections. I think if you click it, Kat, we'll see something else pop up. Okay, we can see that, in April, we all took a step, both as individuals and as organizations. Our organizations had us go home to work. And as individuals, we decided we would work from home and we would stay at home. And you can see what it did. It flattened that curve. It really made a difference. Next slide. And the next flattening off, I think it is attributable to the beginning to adopt masks as cultural norm, as that simple non-pharmaceutical intervention that we can do to change that curve. What's going on? I think it needs some more work up there on the right. We probably need some more cultural, organizational, and individual actions to really begin to move out of this, plus some science such as the vaccines we see coming down the pike. Next slide. But who's impacted? Then this is just looking at New York. You can see that, if you lived in New York and you were a non-Hispanic white, this spring you had a 8% chance of getting the population got infected. Next slide. Whereas if you were non-Hispanic Black, 18% of the population got infected. Next slide. When if you were a Hispanic, 28% of the population got infected with COVID-19. Clearly, like climate, COVID has been disproportionately impacting the minorities in our culture. Next slide. And try once more, Kat. Thank you very much. And I just sometimes have to put a face, just like I need to put a face on the Katrina number here, experience here in my own community. While the hospitals were worrying so much about getting protective gear for the doctors, they neglected to get protective gear for the clerks. And one of the first deaths in our community was actually a clerk at the hospital who, a single mom who didn't have the same protective gear that the doctors had. Next slide. So again, this is really the COVID issue. Is pretty much it's the same story as climate. We have the knowledge base, it's time to act. And the vulnerable are the ones who are impacted first. Next slide. And it's also a moment in our cultural history. Next slide. In the middle of all of this, things that had been happening were no longer being just let happen. We were in a moment where the systemic racism that's been so much part of our culture, whether it was bird watchers, whether it was Christians Cooper's bird watching in Central Park, or the tragic murder of George Floyd, this was no longer simply another number. It was a moment where culturally we decided we were going to stand up for this and stand up for change. Next slide. Scientists stood up and spoke out against racial injustice and discrimination. AGU stepped forward quickly. Next slide. And it was interesting because, next slide, scientists don't always speak out, but, and we didn't quickly speak out when the Black Lives Matter movement started, but this was a moment where we believe that there's a moment for change, and it was essential for solidarity and outrage. Next slide. Is change possible? I've seen change, and I do think it's possible. And that's why I'm so adamant that now is the time that we can address all of these problems simultaneously. Next slide. You might have seen this map. It was it's probably on the wall at the school there in Miami. It's Marie Thorpe's map of the bottom of the ocean floor. And when I came here, next slide, here to Lamont, which was her home institution, now she's considered a hero, but not so much so when I started graduate at school here. She was persona non grata. No one would speak to her. She sort of ghosted around. All the women in seismology were flunked the year I started graduate school. There was widespread sexual harassment of graduate students, and that was just considered okay. And there were no women faculty. And Marie just was a ghost. Next slide. Change is possible. This is the same dress again, obviously. That's a dress with a radar image on it. That's the Gimberts of Mountains. That's Ramo, who received the Ewing Medal that year, who is now the director of Lamont. I applied for and spent 5 years working on diversity here at the Earth Institute through NSF funding, with the goal of changing the demographics and moving women into both faculty and into leadership positions. So I'm very proud that one of your speakers from last year, Maureen Ramo, is our first female director of Lamont. You may have seen a lovely piece on her in the New York Times. Marie Tharp is considered a hero. Women go in the field all the time. And AGU was the first scientific society to define harassment and bullying as scientific misconduct. So I have seen change. I have seen change around the issue of gender. I think now change is possible around the issue of the systemic racism that's in our science. Next slide. Why is diversity important? And diversity, all research on productivity shows that diverse groups are more innovative, more creative, produce better science, and are better educators. Isn't that what we want? Besides it being the morally right thing, it makes better science and better education. Next slide. And earth science does have a whiteness problem. It is the whitest of all sciences. You can see it down there at the bottom in the brown, when there's been very little progress. So next slide. Change is now the moment. My friend Peter Coleman, who has studied destabilization, says that destabilization through major shocks is when you have a moment to change things. You break down the drivers to the problem, and it's a moment. That's why this is the moment for change. Next slide. And if you want to think about it in terms of a graph, you can actually move yourself from one state to another, because now is a time when you can actually talk about fairness from diversity and fairness in conflict. Next slide. Again, you're going to hear the same sort of 3 ways we can address these problems. We can address it individually through personal education and awareness. Be aware of our unconscious biases. Think about who you avoid, who you include. Expand your comfort zone. And think about proactively using your privilege for good. Next slide. Individual, read, learn, discuss. This can be hard, but it also can be fun. Take the Harvard implicit bias test. Look at community resources. You all can be leaders. Next slide. There are lots of good resources online, whether you want to look for talks on implicit bias, on how to overcome biases, on how to use your privilege, or just reflecting on the moment, on race and racism. Many resources, lots of good things to discuss with your colleagues. Next slide. Organizationally, we all are part of organizations, and it's time to really address those inequitable barriers and biases. Look at the policies we have, whether it's at the at the University of Miami or whether it's in a not-for-profit you work for. Look at those policies and practices. Figure out how you spend money, how you govern. Ensure everybody has access to resources. Next slide. I mean, and remember, we want to welcome Black scientists. This is just a sampling of some of the scientists that Nature interviewed just as things were exploding this summer. My favorite is the lower right, Hakeem Abdi, who started working for me about a day. He's one of the ones who made that 3D image you saw, the Gamberts of mountains, and now he has a PhD in physical geography. Next slide. What has AGU done? AGU very clearly set down focus areas. I don't need to read them to you. They're very much based on you have to say what you're going to do. You have to have a plan. You have to commit to diversifying and making a truly inclusive space. Next slide. Culturally, you have to evaluate what your norms and your behaviors are. This year has really made me reflect on moments I've seen tremendously racist behavior go by and not said anything. I have not practiced intervention in the past, and I need to work on, and we all need to work on challenging stereotypes and our prejudices. This is work, but having seen our culture change for women in science, I'm convinced this is the moment we can change for people of color, and that our science will be better once we step forward. Next slide. Things we can do. This applies to everything. This is 10 simple rules for building an anti-racist lab, but it could apply to anything. Discuss it. Again, that's back to talk about it. Talk about racism. Address it in the field and in the lab. Figure out how to collaborate with your BIPOC colleagues. Mentor well. Advocate. Amplify the voices of BIPOC scientists in your field. Support them. Recruit students and staff. Think about what you're researching. Are you not embracing environmental justice as a robust field of study? Advocate for racially diverse leadership and hold people accountable. Pretty simple 10 rules. Next slide. So, I'm not going to go back over them, but it's just like we saw for the other issues. There's an individual, an institutional, and cultural change needs to happen. Next slide. So we're in a pretty unique moment. And as Peter Coleman says, this is a moment where we can trigger change. But we're geeks. We can work on this tough problem, and we all have those levers we can choose to foster change. Next slide. I have this vision that's I helped write the new AGU strategic plan, and it's one I hold dear, is that we really want to have a thriving, sustainable, equitable future supported by discovery, innovation, and action for everyone, because that's what we need to address climate, COVID, and racism. Next slide. Thank you very much for inviting me today, and I hope you've enjoyed this whirlwind tour from ICE to racism. Next slide. Thank you very much.
Thank you so much, Dr. Bell, for this very inspirational and informative talk tonight. I believe most, if not all of us, agree with you that change is possible and that we all need to be a part of it. And before we get to Q&A, I want to thank everyone for coming tonight and being a part of this very important and topical conversation, and to also keep an eye out for the Sea Secrets lineup coming up for spring 2021. And so with that, the first question I want to ask is, came from earlier in your talk. You had talked about sea level, the sea level going down in some places. Can you talk a little bit more about that?
Isn't that just so mind-boggling? It's like so cool. Some places, there's two reasons sea level goes, there are a bunch of reasons sea level go down, but some of you guys are probably sitting on a couch or in a comfy chair. When you stand up, that couch or that comfy chair is going to bounce back up. That's the same thing that happens when an ice sheet melts. So you saw that some of the places where sea level is going down is actually where there used to be an ice sheet. Scandinavia used to have a big ice sheet sitting around it. So it's going up this much every year because it's still getting unloaded from the ice sheet. The other place, the reason that sea level is going down is actually why I'm working in Greenland right now, is there's actually gravitational attraction between the ocean. Maybe we can do this. If this is the ocean and this is the ice sheet, the ocean actually piles up close to the ice sheet when it's there. But if the ice sheet gets lower, there's less mass to attract it. So the sea level close to an ice sheet falls down. So in fact, around Greenland, we're seeing the land come up and the sea level fall. And around Greenland, they're having exactly the opposite problem to what you're having in Miami. In Greenland, they're finding places they're running into rocks because the land is coming up out of the ocean.
Awesome, thank you. Next question we have is, in view of everything that is happening right now, what do you think is the most optimistic and catastrophic scenario in this global situation?
Okay. The catastrophic situation is that we continue to have governments that don't honor science, large governments, and will continue to drive us towards catastrophe, and that don't accept that and the science of diversity, and we continue to be fractured. That would be my nightmare. My optimist, because I'm going to end on the optimist, not the nightmare, is that we see grassroots efforts to embrace science. We see the major governments embracing science to a place where we can have science that guides us through decisions that will allow us to mitigate climate change, address climate change. It will allow us to move through this pandemic area and actually address racism in a way that we never have before. So that's my optimistic view. And I will admit, I am quite, seeing a president and a president-elect who spoke of science and spoke of systemic racism warmed my heart, because we must address these issues and climate.
All right, so next question we have is, where is the water that is found under the ice sheet? Is it water that is trapped, untouched from the outside environment? If you took an ice core that drilled into those clouds, I'm putting in quotes, what would you expect the gas concentrations to look like, today's or historical?
Oh, such a good question. First, water from the bottom, water under the ice sheet is actually melted ice from the bottom of the ice sheet. Unless you're right next to the edge in Greenland. Even though the average temperature at the top of the ice sheet is -50, at the bottom, because of the geothermal heat coming up, it's really close to freezing. So it's like -2, -3. So it's close to melting. So much of the ice sheet where it's really thick is actually melting at the bottom. So there's water there. What's the chemistry? So the chemistry is like old, it's going to be old water. It's gonna be mixed. We have drilled into that kind of ice at Vostok, and you see it's less acidic. It's lost some of the particles that make ice normally acidic, and it's has big crystals and has no bubbles in it. So those are some of the predictions I'd make about what those clouds, I'd predict they have really big crystals, and the chemistry would be reflected of relatively old chemistry, because it's equivalent to basal melt. So somewhere between 300,000 and 700,000 year old chemistry.
All right, so we've got 2 more questions. First one is it important for cities to map entities on a sustainability scale for investment and resource deployment? And do you think institutional investors using environmental, sustainable, and governance metrics will make a difference in helping climate change?
I missed the first one, so I'll start with the second one, then you can tell me the first one. Yes, I think it's really important. I mean, it's something at AHEU we've done. We spent a lot of time worrying about investing in ESG, environmental sustainable investments. I do worry whether or not some of it's relabeling, but I think you have to try and push every lever. And to make a direct impact, I think you have to go more in the venture capital world as opposed to major stocks and stock funds. But I think it is important. And tell me what the first question was, Josh. Sorry.
Is it important for cities to map entities on a sustainability scale for investment and resource deployment?
Oh, I think it is important for cities to map what, oh, come on, I map everything. Of course they should map things.
And actually, I've got one more really quick. So regarding the climate change as a public health issue, the US has not done a great job with COVID. No. What can we learn from our struggles with public health compliance with COVID-19 in the US, and how can we apply these lessons to addressing climate change?
Ka-ching, that's a $64,000 question. Some is, probably central to this is figuring out how to depoliticize it and how to make it clear that by acting on the science, you're going to help the economy in the long run. That those are probably the two issues. If this wasn't political, we'd be all doing much better. And then if we were embracing the science results and using that to derive decisions, while it might have a short-term impact on the economy, using science-based decisions, both in climate and in COVID, will get you to a good place with your economy quicker.
All right, and I think we're going to wrap up here. So thank you so much to Dr. Robin Bell and to Hilary Sunell for talking with us all tonight. Hope everybody has a great rest of their fall going into winter, and we'll see all of y'all in spring. Take care.